So welcome to a rationale-based classification of MISRA C guidelines. This is Lavinia speaking. I'm your host for today's webinar. Today, BUGSENG is happy to host one of its founders, Professor Roberto Bagnara. Roberto is a well-known expert when it comes to MISRA as well as functional safety. He is a member of both the MISRA C and the C standardization working groups. He's been BUGSENG CTO for many years, and it is always a great pleasure to have him as a guest on our webinars. Our everyday work at BUGSENG revolves around quality, reliability, and competence. We are known for our static analysis platform, Eclair, for our MISRA trainings, and for our highly specialized consulting services. In almost everything we do, MISRA plays a major central role. We strongly believe that the MISRA guidelines are highly beneficial for all sorts of projects. Safety and security critical, of course, but also for projects with less strict requirements. So today we present a classification of the MISRA C guidelines that will significantly help your teams in selecting the subset of the guidelines to be prioritized, basically. Right, Roberto?
Yes, exactly. Okay, so let's start. I guess you can now see my slides again.
Yes.
Okay, so you can see that this is joint work with Abramo Bagnara and Patricia Hill. So here is a brief outline of my presentation. And before going into it, let me start with disclaimer number one. As Lavinia said, I am a member of the MISRA C working group and of WG14. And Patricia Hill is a member of the MISRA C++ working group. However, the views that we express in this presentation are ours and not necessarily represent the views of either working group. And also, in view of this disclaimer, I have a disclaimer number 2, which is very important. So the notion of MISRA compliance is as defined in MISRA Compliance 2020, the official document that explain upon which conditions you can claim a project to be MISRA compliant, and there it stays. So even though I will talk about subsetting the MISRA guidelines, meaning prioritizing some of them over others, and nothing in this presentation is meant to change any of the conditions upon which the project may legitimately be claimed to be MISRA compliant. So I'm sure that everything will be clear at the end of the webinar. So let's start with some introductions. The C language. The C language is, I think this year is the 50th year since the introduction of the C language, which was in 1972, and it is still the most used language overall, and especially in embedded systems. And the reasons are well known. There are very strong economic reasons. So there are compilers for almost any processor. The code is very efficient and it has no hidden costs, basically meaning that if you look at the code and you are an experienced programmer, you can more or less guess what the execution time will be. In C, you can write quite compact code and do interesting things with very few lines of code. It's a language which is defined by an active group and by an ISO standard. And with extensions, the C language allows easy access to the hardware, which is essential in embedded system programming, for example. And it has a longer history of usage, including in critical systems. And there are tools for C to do basically anything you may wish. So there are tools for really a lot of software engineering related practices. So C has also disadvantages, and the disadvantages come from the fact that well, it's a feature. So the standardization group has always been faithful to the original spirit of the language. And the following points are taken from the charter of WG14. So point A, trust the programmer. Point B, don't prevent the programmer from doing what needs to be done. Okay. focus on point E, make it fast, even if it is not guaranteed to be portable. So speed is one of the main priorities. Only in 2007, in view of what became a C11, the following point was added to the charter. So make support for safety and security demonstrable. It is fair to say that realization of point F is still in progress, largely. Now, so given that several features of C conflict with safety and security requirements, what is the solution? The solution identified by industry is very pragmatical. It is called language subsetting, meaning you don't program in C, you program in a safer subset of C. And language subsetting is mandated or recommended by basically all safety and security related industry standards. And the most authoritative language subset for the C programming language is MISRA C, and this is why we talk about it today. So let us talk about classification of MISRA C guidelines. There are several classifications that already exist in the MISRA documents, and 5 are already existing. So every guideline is in one series, and a guideline might be a rule or a directive independently, and every guideline has a category that may be mandatory, required, or advisory. A guideline may be decidable or undecidable, and a guideline scope may be a single translation unit or system. While the first axis is just for presentation convenience, the last 4 axes have very deep consequences on the notion of MISRA compliance. We now will go through all of them, starting from axis 1, the series to which the guideline belongs. And this is the first number in the numerical part of the guideline identifier. For example, rule 8.1 belongs to rule series 8. And the series are in one-to-one correspondence with what is called the main topic of the guideline. So basically what the guideline is talking about. And for example, for rule series 7, 8, and 9, we have in the MISRA document 3 sections, 8.7, 8.8, 8.9. And in section 8.7, the main topic is literals and constants. So this is the main topic for series 7. For series 8, the main topic is declaration and definition. And for series 9, it is initialization. So you see that these are very broad categories that are convenient, essentially for presentation purposes. Actually, there are guidelines that would that could be placed in different sections, because indeed choosing what is the main topic in some cases is not easy. Then axis number 2, rules and directives. Every guideline is classified as either a directive or a rule. A rule is a guideline such that all the information concerning compliance is contained in the source code and in the language implementation. Notice, I always stress this point. A piece of source code means nothing. Int X means nothing. Until you know how many bits in your implementation is an int X means nothing. Okay, this is why I always stress that for a rule, the information concerning compliance is fully contained in the source code and in the language implementation, taking into account all the implementation defined behaviors of the language. And there are more than 100 in each version of the language. And otherwise, if it is not a rule, it is a directive. It is a directive because all the information is not there. So you may have to take into account requirements, specification, design, in some cases also the programmer intention. So a tool may give valid assistance in checking a directive, but only if you provide the tool with the information the tool cannot gather by itself. Axis number 3, very important, the guideline category. The category may be mandatory, required, or advisory. Mandatory guidelines are non-negotiable. Deviation is not permitted. So if you want to have a claim of MISRA compliance for your project at the end, you have to comply with all the mandatory guidelines. Required, you have an option. You may comply in basically in two ways. You may have your code complying or your process complying with the guideline, and otherwise you will have to raise a formal deviation. Formal meaning that it has to be a written deviation. You must come up with a written argument on why safety is not compromised, even if you are not observing the rule in one instance or in several instances. Advisory guidelines are recommendations, so they should be followed as far as it's practical to do so. And formal deviation is not required, but non-compliance should be documented. Okay? And there is no other grading of importance of the guideline in MISRA C. So all the required guidelines, whether they are rule or directives, are of equal importance. Okay, and mandatory is more important than required, and required is more important than advisory. So as far as the MISRA C is concerned, this is the only classification of importance. Axis 4 is decidability of the rules. So the rules are classified as either decidable or undecidable. They are classified as decidable when there exists an algorithm that for each source program, given enough resources, meaning given enough memory and enough computation time, will always produce a yes or no answer in finite time. In this case, the rule is decidable. And when such an algorithm does not exist, and typically when it does not exist, it will never exist, such rule is marked as undecidable. Of course, limitations of available resources might prevent the use of the exact algorithm, even when the rules are decidable. This is a choice that every tool makes in order to solve the complexity precision trade-off, which is very acute in static analysis, in order to satisfy its particular audience. Axis number 5, scope of the analysis. The rules are classified according to the amount of code that has to be checked at once. So single translation unit guidelines are such that all the violation within a project can be found by considering each translation unit at a time independently. Okay, a translation unit is, say, a C file, .c file with all the other files that are included by it. And if it is not a single translation unit, then it is tagged system, meaning that identifying violation of the rule requires checking more than one translation unit at a time, possibly all the source codes that constitute the system. So these 5 existing axes are not completely independent. In fact, you can observe that all the undecidable rules have scope system, because when a rule is undecidable, it depends on the semantics of the program. And the semantics of the program can only be known if you have information about all translation units that are linked together to form the program. So these were the existing classification, and here we present a new classification of MISRA C guidelines, which is rationale-based. What do I mean that it is rationale-based? That the guidelines are grouped together in according to their main rationale. The rationale is what is contained in a section in the MISRA document for each guideline, where the reader is told why the rule exists, why the guideline exists, what are the phenomena that the guideline is meant to prevent. So in this new classification, we grouped the MISRA C guidelines, which are 175 in total, in 1 or 2 of 16 named sets. So there are only 3 guidelines that belong to 2 sets, Rule 6.1, Rule 8.6, and Rule 22.5. And the reason is that they have two rationale, and so there really is no other solution than duplicating them and putting them in more than one set. So, and here is the synopsis. As you can see, there are the sets are defined by a 4-letter abbreviation, which is written in red. Another thing that I want you to observe is that in this synopsis, we can see many of the classifications. For example, we know that the series is the first number. So directive 2.1 belongs to series 2. Okay. And whether it is a directive or a rule is written explicitly. And the guideline whose identifier is written in boldface, they are the mandatory. The ones that are written in normal font, they are the required. And the ones that are written in italics, they are written in, they are the advisory guidelines. Okay, so I will go through this, the meaning of each set. So CTIS means compile time issue. Runtime issue is RTIS, but just to give you a flavor of how the classes are done. So HTDR means hard to do right. I will explain later what we mean with this. Okay, so we have seen the 16 classes now. So let us now explain briefly all of them. So take into account that there is an accompanying paper which you can well, I don't know, you can download from several places. I guess it is in the proceedings of Embedded Word 2022, and I don't know if it is available also somewhere else, but in the post-webinar mailing, I'm sure you will be told how to obtain the paper. And so the first class we see is called LTLM, which means Language Toolchain Library Misuse. And these guidelines are extremely important because we can program in C only if we play by the rule. We can program in C reliably only if we play by the rule. So we have to comply with the language specification. So the standard, the C standard we have chosen, the toolchain specification, and the standard library specification. If we go outside the rules, then there is no guarantee a priori. We may find our own guarantees, maybe, but this will be expensive. We will have to find that indeed there is no problem. So, for example, rules belonging to this LTLM class are Rule 1.1, saying that the program shall contain no violation of the standard C syntax and constraints, and shall not exceed the implementation translation limits. So you see that here we have a first part of the rule before the comma has to do with the language specification, and the second part shall not exceed the implementation translation limit has to do with the language specification and the toolchain specification. So every implementation of C has limits. Okay, and for example, there may be a maximum number of cases in a switch, and you have to be aware of this, because if you exceed this limit, your toolchain, your compiler may do something that you don't expect. Rule 9.1, it's the well-known mandatory. So you shouldn't try to read a value from a stack variable that has not been initialized. And Rule 21.2 has to do, of course, with the toolchain and with the language specification and the standard library specification. So a reserved identifier or reserved macro name shall not be declared. Otherwise, you would break the namespace of the implementation, and anything may happen. The class, which is called DevM, means developer misreading, mistyping, misunderstanding. And these guidelines are there, they're rational, is to prevent mistakes that arise from three phenomena. So first, developers are often not aware of all the C language intricacies. There are really many. C is a complex language. So you may think that it's simple because maybe you program in a certain fragment, but the point is that even that if you stick to a small fragment, there are many subtleties that you must be aware of. Phenomenon number two is the developer is misreading or misinterpreting program elements. So there are guidelines that have to do with avoiding so-called developer confusion. Okay, and third phenomenon, developers typing something different from what was intended. So of course, it's always possible to commit a typing mistake. So here is a good example. Rule 12.5, which is a mandatory. The size of operator shall not be an operand, which is a function parameter declared as array of type. Okay, maybe the intention of the programmer was to obtain the size of the array, measure of the size of the array in bytes maybe, but due to array decay, what we are actually computing with this is the size of the pointer to a member, to an element of the array, which is completely different. Or maybe the programmer mistyped it. The programmer didn't want to write size of A, where A is a function parameter of array type. Maybe the programmer wanted to write size of A of 0, so to obtain the size of an element of the array. CTIS, compile type issues. These are all directives that have to do with the possibility that you may end up with executable code that doesn't match the source code. So Directive 2.1 is all source files shall compile without any compilation errors. You might think, hey, well, the compiler no modern compiler will dare to produce code even if there is a compilation error, which is not strictly true. There are legacy compilers still in use that do produce object code also in presence of an error, but the directive has to do also with your build procedure. So modern projects are typically complex, and so you will typically use some sort of scripting or make files or Ninja input, and you may make a mistake of ignoring an error returned by the compiler. So there are ways in writing a make file whereby you may invoke a subprocess and ignore the status that is returned. It's a costly mistake because maybe the old result of the compilation is there. It was referring to a previous version of the source file, and the linker will find it. And so in the end, you will end up with an executable that doesn't match the current status of your source code. Another related guideline has to do with the presence of guards against multiple inclusion in header files. Runtime issues. This is class RTIS, and this guideline covers runtime issues that are not covered by other rules in the set. So, for example, Directive 4.1 saying that runtime failures shall be minimized, and Rule 22.1 saying that you have to explicitly release all the resources, not just memory, but all the resources that you have obtained dynamically by means of the standard library functions. DOCU is for documentation. This is an easy abbreviation. And of course, documentation is one of the key distinctions between hobbyistic programming and professional programming. So, for example, here we have Directive 1.1 saying that any implementation defining behavior on which the output of the program depends shall be documented and understood. You cannot risk that somebody in the team is not aware of, for example, how bit fields are mapped into memory words and let people use bit fields like this. So it's everything is implementation defined, for example, for bit fields. So you have to be aware if you use them. And Directive 3.1 says all code shall be traceable to documented requirements. Of course, for professional programming, starting programming without requirements is pointless. And also Directive 4.2, all usage of assembly language should be documented. There is a class that has to do with encapsulation modularization, ENMO. And this contains all the directives that promote encapsulation and modularization, which are things that are very important. They facilitate testing, and they also, of course, facilitate the development of the project. In fact, the guidelines in this class, well, if you are at the beginning, as you should, well, if you have a MISRA compliance requirement, and then and you are in position to abide by the common recommendation to start MISRA compliance immediately, many of these guidelines will simplify your work. So we'll make sure that you have encapsulated and modularized things in such a way that prevents the misuse of certain modules in your project. HTDR, hard to do right. So there are many features in the C language that are harmful. They are very dangerous. At the same time, they are also very useful. So they require considerable expertise. And so as I will say later, so if you are some in the team comprised in the team, you have persons that are say juniors that are not say that have not a long experience of programming. Well, they should probably stay away from these features, or seek for assistance for someone who is more expert. So typical examples are dynamic memory allocation shall not be used, Directive 4.12, and Rule 17.2. So functions shall not call themselves either directly or indirectly. So recursion is vastly useful. So for example, if you want to write a compiler, well, you basically cannot do it without recursion. But this is it's not the typical kind of software you would write in embedded systems. So recursion is also very dangerous. So, well, if you think you need it, you have to take a lot of precautions to do this in a safe way. Then there is a class containing only one rule, emergent APIs. So these are the features of C11 and C18 that have not yet been considered with MISRA C. Actually, the MISRA C working group is working actively on reducing the scope of this rule that today say, don't use type generic expression, don't use no return, don't use atomic, and so on. But very soon the MISRA C consortium, the MISRA consortium, sorry, will publish an amendment to MISRA C 2012 that will cover this some of these features. Then there are badly designed or obsolete APIs. So these are notorious to be unsafe by design. So for example, the standard library function to convert strings to numerical data, so A to F, ASCII to float, or A to I, ASCII to int, they have undefined behavior. In the case the input string cannot be converted, there is no reason whatsoever to use them, because since many years there are safe replacements. So for example, STR to L to convert a string to a long in a safe way. And also Rule 21.11 is in this class. The standard header file tgmath.h shall not be used. So if you don't know what tgmath is, well, good. Don't worry. Don't use them. Don't include this header file. Portability. Guidelines in this set have as their main rationale portability. So, for example, Rule 1.2 says language extensions should not be used. Of course, if you use extension provided by your compiler, this may not be provided by another compiler, or worse, the other compiler may provide something similar, maybe with the same syntax, but with a slightly different semantics. So this is a good reason to avoid extensions if you care for portability, or to use them in a very careful way. Rule 6.1, bit fields shall only be declared with an appropriate type, again, because if the type is not, well, of what is an appropriate type is, of course, written in the MISRA book. And if the type is not appropriate, then the behavior may change from one implementation of the language to another. Compile time information loss. So the rules in this set have as their rationale the fact that you should give the compiler the possibility of rejecting your code, or of warning about suspicious condition in your code. Here is an example. So a string literal, rule 7.4, shall not be assigned to an object unless the object type is pointed to const qualified char. What's the point here? The point is that for a history reason, for historical reason, the type of a string literal is char pointer. It's not const char pointer. At the same time, if you try to write to a string literal, it's undefined behavior. So by complying to this rule, you will only assign string literals to const char pointers. And so the compiler will give you a compilation error whenever should you try, maybe by mistake, to write to this string literal via the pointer. Runtime information loss. So it's similar, but here the information loss, the information before you are losing type information, for example, the constness, the const nature of string literal you are losing by violating this rule. Here, you might ignore or corrupt or erase the information that is available at runtime. For example, rule 16.4, every switch statement shall have a default label. So if you don't have a default label and no case applies, then the switch will do nothing. And maybe this is not what is not the correct course of action. Tainted input. So an input from external sources, if it is not properly sanitized and used directly, it's risky. So the input is maybe provided by a malicious person, because maybe you are under attack. For example, if you take a value that is communicated from the outside world and use it to determine an array index, then you may have a buffer overflow, for example. Or if you use it as a divisor in some division operation, you may have a division by 0, and so on. So this is why you have Directive 4.14 saying the validity of values received from external sources should be checked. Shall be checked, sorry. Irrelevant code. There are 6 guidelines here, and there is this set coincides almost with series 2 of MISRA C, which is called unused code, with one exception. So there is the rule 8.6 that belongs to series 8, and it says an identifier with external linkage shall add exactly one external definition. So for the case where, so exactly 1 means 0 is not good and more than 1 is not good. If you have 0 definition, then it's irrelevant code. What is irrelevant? It's irrelevant the declaration. So if you have zero definition and you don't use the function, you have no linking error, but still the declaration is irrelevant. Why is it there? And otherwise, if you use the function, you will have a linking error. But so for this case, for the case of zero definitions corresponding to a declaration of an external identifier, for the case you don't use it, is irrelevant code. Type misuse. These are the rules that guard against basically the risk of implicit type conversions. So the type conversion, the implicit type conversion rules of C are quite intricate, and so programmers often don't know them completely. And so there are several rules that are there in MISRA C to mitigate this problem. For example, rule 14.4, saying that the controlling expression of an if statement and the controlling expression of an iteration statement shall have essentially Boolean type. So they have to be Boolean in nature. CSTR is a class of code structuring guidelines, and they define a subset of C that is easier to review, to maintain, and to analyze. Okay, several of these rules define a restricted format for the selection and iteration statements. You know that the switch statement in C is not like the case statement in Pascal. The switch statement in C is a computed formalism, and that can express computations that are quite intricate. Inside that switch, you can put a loop. Many of you will have heard about the DOCU device, and if you don't know, then search on Google DOCU device, and we will find something very instructive. Now, this was the new rationale-based classification of the MISRA guidelines. So how to use it? There are several uses. So the one very important thing is that it's a very compact encoding of the rationale. Of course, it's a rationale-based. So it allows programmers to quickly and more faithfully reconstruct the guidelines objective, and also using this reminder about the rationale of the guideline, they will typically make better choices when choosing whether to comply or to deviate. Okay, and this is important because unfortunately, not all programmers are suitably trained in the MISRA standards, and so a quick reminder of why the rule is there is very often beneficial. In some cases, the programmer doesn't know what is the rationale, and this quick reminder, we have seen they are really beneficial. So, and in particular, every class of this new classification can be associated to questions that explain what is the nature of the issue. For example, LTLM, library toolchain library misuse. The question is, do I really want to do that? Do I really want to go outside the C99 standard, for example? DevM, so developer misreading, misunderstanding, mistyping. Am I sure about what the C standard prescribes here? Did I make a typing mistake? Can I clarify my intention? Compile time issue. Do I trust my build procedure? Do I have multiple inclusion guards in place? Okay. Runtime issue. Did I exclude or mitigate possible runtime errors? Documentation. Is this documentation available? Where is it? And encapsulation and modularization. Will we need to maintain this program or to extend this program or to work further on this program? Hard to do right. Did I consider the intricacies of this language feature. For the classes of embedded designed API and emergent API, the question is the same. Do I really want to use this API? Port, the question is, of course, is portability among the project objectives? Because if portability is not an issue at all, then you might look at the guidelines in port with a different eye. CTIL, can I get this right without compiler assistance? So compile time information loss. Can I really do without the assistance of the compiler? RT runtime information loss. Am I losing valuable information here? Tainted input. Is this input tainted? If so, can it cause R? Irrelevant code. Why is this code here? Maybe it's a relic from the past. Maybe it is the result of an incomplete refactoring. Maybe it can also cause problems. Type misuse. Can this result into a runtime type error? Am I willing to run the risk? And code structuring. Can I make this code easier to understand? Okay, so this is how everybody can use this new classification as a quick reminder of what is the rationale of the guideline. Then there is the possibility of subsetting. And subsetting is for two classes of projects. So let me repeat once again that in order to formulate a proper claim of MISRA compliance, there is no shortcut beyond what is prescribed by MISRA Compliance 2020. So, and for MISRA Compliance 2020, subsetting yet obtaining a MISRA compliance result, you can subset only the advisory guidelines subject to certain conditions. Okay, the notion of partial MISRA compliance doesn't exist. Okay, I mean legally it doesn't exist. And still, why did we work on this classification? Because the vast majority of projects and organizations do not have a MISRA C requirement. Some of them do not yet have a MISRA C requirement. As you know, the criticality of the devices and of the functionalities that are assigned to software in the devices is continuously increasing. So not having a MISRA requirement today doesn't mean not having it tomorrow. And in addition, there are too many projects out there that are still at the situation, no coding standard, no static analysis, they do nothing. So this is a problem. And for this project, for the projects that do not yet have a MISRA C requirement, in a presentation we gave to Embedded Conference 2021, which I think is already present also on BUGSENG YouTube channel, we recommended as one possibility the embracing the BAR-C 2018 coding standard. And here we propose an alternative. To the project that do not yet have a strict MISRA compliance requirement to adopt a subset of MISRA C following the rationale-based classification. So let's talk about this project. Projects that do not have already a strict MISRA compliance requirement. So our recommendation is to first enforce the guidelines in LTLM. Library toolchain library misuse. Okay, they concern harmful situations that should always be avoided one way or the other. Okay, then if time allows, then also enforce the developer misunderstanding, mistyping, misusing guideline. So the violation of this guideline often are maybe harmless, but they are easy to avoid, and solving them reduces the risk of misleading other members of the team. Then if your project, if portability is one of the objectives of your project, then add the port set. If you have inexperienced programmers in the team, then add the HTDR. And if you want to have more maintainability and the possibility of reusing the code for other projects, then add the encapsulation and modularization class. Okay, so I prevent one of the questions that in a previous instance I have been asked. So are you suggesting that the Linux kernel should adopt LTLM? And the answer is yes. Okay, so and then the classification is also for another set of projects, those that do have a MISRA C requirement. And unfortunately, as everybody knows, that the maximum payoff from the adoption of MISRA is if it is adopted at the very beginning of the development. And this often doesn't happen for different reasons. Okay, so in these cases, prioritization is important. So you may know in advance that you will not be able to look at MISRA compliance at all of it at the beginning. But using this classification, you might avoid procrastinating the compliance to some to guidelines that you will pay dearly later. Okay, so it may be acceptable to postpone, for example, compliance with the guidelines that have to do with unused, unreachable, or dead code, but other guideline subsets need to be considered earlier. So if you know you will have to procrastinate part of the MISRA compliance work, here is our advice. First, make sure that the documentation required to comply with the DOCU guideline is available. So really, you cannot procrastinate the availability of requirements or of information about the toolchain implementation, defined behavior, and so on. Then enforce LTLM. And this, when you have enforced the LTLM set of guidelines, you will have fixed the C dialect, and which means that at this stage, in case you have to do compiler qualification in addition to MISRA compliance, then you will be able to start compiler qualification earlier, which is always good. So you don't want to discover later that you have relied upon features of the language that your compiler doesn't translate correctly. So you want to know as early as possible. Then focus on the type misuse guidelines. And the reason is that if you wait too much, you will end up at the end of the project with tens of thousands, hundreds of thousands. So in some cases, we have observed millions of violations of rules in this class. And then it will be very expensive to fix all of them. And this will require reworking and refactoring. So you want to avoid this, because otherwise the costs will increase. You will have project delays, all sorts of bad things may happen. And also the DevM and HTDR guidelines should not be delayed too much if the amount of code still to be written is substantial. And that's it. So if you really have to procrastinate part of the MISRA the compliance work, do not procrastinate these classes. So in this order of priority. And then if you have to, you can leave the others for later. So time for the conclusion. I think I'm not late. So we have presented a new rationale-based classification of the MISRA guideline, and this is orthogonal to the classification provided in the MISRA documents. And one of the good things about the classification is that it reminds programmer of the main rationale for each guideline, and this way they will more easily identifies the right course of action. Should I comply? Should I modify the code? Maybe I should deviate. What is the rationale of this guideline I'm violating here? And the new classification also helps prioritization and encourages not to procrastinate the complete MISRA compliance effort. So please do not take this talk as, this talk says that you can procrastinate. Well, no, it says if you really have to procrastinate, at least procrastinate intelligently. So follow this classification, and the extra cost of procrastination, because procrastinating produces extra cost, will be minimized. And another advantage, which we regard as very important, is to open the door to projects without MISRA compliance requirement. As I said, there are too many projects that are at the stage, no static analysis, no coding rules, nothing. And one of the reasons given is that, well, MISRA compliance is too complicated. Well, it is true. It is complicated. So it requires it requires tools of high quality. It requires expertise. It requires training. Well, if you adopt a subset, and especially the subset we indicated in this talk, then your project will be much better off. And for those projects, for those projects that do not have a MISRA requirement, this also encourages the use of good tools instead of using, for example, bug finders, or using only compiler warnings that in many cases are unreliable. Instead of using open source tools, CPP check, for example, that have a performance that is not acceptable in safety critical development. And that's it. And if you have questions, please let me know. I am only seeing my slides, so I don't know.
Thank you. Right. Let's start with a first question. So can some MISRA guidelines be disregarded altogether?
No, they cannot be disregarded altogether, meaning that if the project has to be MISRA compliance, then you can disapply. If you follow MISRA Compliance 2020, MISRA Compliance 2020 gives the possibility of disapplying the advisory guidelines, a selection of advisory guidelines, by simply giving a rationale for this application. For example, for automatically generated code, the guidelines that have to do with code readability and code maintainability and things like this, those that are advisory can be disapplied. And the rationale is we have qualified the code generator. Nobody will have to read, understand, let alone modify the C code, which is automatically generated. For this reason, on the automatically generated code, we decide to disapply guidelines X, Y, and Z. So you cannot disregard any guideline. Simply, some sort of thinking and decision will always have to be taken. But for example, if you stick to MISRA Compliance 2020, and if you decide to disapply certain guideline for a certain part of the code, you don't even need to check the violation in that part of the code. Okay, so I think this answers the question.
Thank you. So Mike wrote, typically, we do not want to claim MISRA compliance as it is expensive to achieve, but we would like to apply MISRA as good practice. MISRA tends to be all or nothing and has no grading to apply it pragmatically to software of different safety classifications. If the software is safety relevant, then all rules apply. it appears that the difference in rigor lies within the deviation process. That is, some deviations are acceptable for lower software safety classes. This classification approach, Mike adds, may help. I'm not sure if you want to add something to this or just.
No, I agree. I agree very much with what Mike said. So it's one of the reasons why we did this classification. So it's I think it's helpful, and I think it is wise to adopt it and to make it known to members of the team as early as possible, because this will also. So in some cases, especially members of the team that didn't have proper MISRA training, they may tend to dismiss the violation. Oh, what's the problem here? There's no problem here. And just being reminded about the rationale, and they may be, so for example, what's the problem here? There is no problem, but the rule is in the library toolchain and language library and toolchain misuse, and the user should immediately will pay attention. So, okay, here I am relying on something that is not guaranteed by the C standard, or is not guaranteed by the compiler, or is not guaranteed by the standard library. In many cases, the user will have to admit that he or she was not aware of the fact that there was something not guaranteed in that thing the programmer wrote. Yeah.
Good. I think I'm going to answer this one. Does Eclair support this classification of MISRA guidelines? Well, sure. Next version of Eclair will include a configuration file where the guidelines are tagged according to the proposed classification. I recognize many of you as Eclair users, and in fact, the configuration file is very trivial. I mean, it's no big deal. If you want, you can request it straight away, and we can supply it even now. Okay. If there are, I think we covered them all. Yeah. This is just consideration. So I'd like to share a couple of dates with you, which might be useful. BUGSENG does a monthly presentation of Eclair software verification platform. And of course, I would like to invite you all to attend the next one, which is on October 10th. You can check out all available dates. There are several, and register on bugseng.com/webinars. You can also check out how the tool works heading over to eclairit.com even now. Eclairit is a public website. No registration is required. It's super easy. Basically, what you can see there is how Eclair can be used in continuous integration with Jenkins and GitLab on several popular open source projects. FYI, will soon release the same for GitHub as well. One last thing, if you have MISRA training in mind, which you probably should, next session is happening in mid-November in English and online, of course. You can check out the full details on bugseng.com/services/training and get in touch with us for any further query. All right, that's all. A special thanks again to Roberto and to you all for being with us today. And until the next one, have a nice day, everybody. Thank you.
Bye-bye.
Bye, Roberto. Thank you.